Okay, we'll go ahead and get started. Again, my name is Erik Bush. I'm CEO and founder of Demand Driven Technologies. Delighted to be your host and presenter here for our webinar today. This is the last in a series of webinars we've run around building supply chain agility and resilience. We're going to focus on scheduling and execution today, and obviously are excited to have all of you in attendance with us. A couple footnotes here as we get started on the webinar. First of all, everyone will be in listen-only mode or muted. That improves the audio quality for all the attendees. Doesn't mean we're not interested in your questions. There may be some questions you want to ask along the way. Please use the question and answer feature within the Zoom panel on your display, and you'll be able to ask those questions. We'll cover those off here before the end of the session. We are going to be doing some polling questions during the webinar today to get some perspective on your own environment and landscape and some of the challenges that you may be facing. So we'd greatly appreciate your participation in those polling questions. We are recording the webinar, and this is for the purpose of sharing it with you. You'll receive a link to the recording of the webinar later today, along with a copy of the presentation materials from the session today. So with that, let's go ahead and dive in. We're going to cover the scheduling and execution phase of activity. So we'll be talking about operations, production, scheduling, and execution, and how we can create agility within that environment. For the purposes of context, I want to start with some of the market realities, and I've covered this on the previous slides in the previous sessions. The reality is that U.S. manufacturing, global manufacturers have really not seen any improvements in inventory turnover rates over the last 25 years, despite the substantial investments they've made in ERP systems and other software solutions. There was a little bit of an improvement in the 2005 to 6 arena, but then when the recession hit, that gradually turned around, and in reality, we are turning today at the same rate we were 25 years ago, and we believe that that represents a big opportunity for companies to make progress in this front as they go forward. We're not going to be so much focused on inventory turnover today, but more the scheduling and operations aspects of that. But clearly, this is also a byproduct of how we use our production resources and how we work with our supply chain functionality in that arena. We do have what's called VUCA conditions: volatile, uncertain, complex, and ambiguous. They are everywhere, and they are impacting our supply chain operations to a very substantial degree over the last couple of years. Obviously, the pandemic had a big contributing factor on that, but even then, other macro conditions such as global competition, the power of the internet as a commercial platform, changes in workforce dynamics, all of these factors are contributing to making executing supply chain more and more difficult as we go through time. With SKU proliferation, item forecasts have become more and more difficult to get accurate, and so companies continue to comment that their forecast accuracy has not really made any tangible progress over the last several years. They're fighting with labor issues now. The workforce dynamics are impacting them, with people choosing different career paths or moving production environments into lower cost countries and not having the same educational standards or training standards. People have selected different job categories that they want to pursue and the like. All in all, these have created a number of challenges for our clients around the world. Even obviously the pandemic, which it appears that COVID's not done with us. There's still a bit of a wave developing with a new variant that's been detected. This results in a lot of firefighting, a lot of workarounds, and very, very challenging conditions. So against that, I think there's been a real striking audience for people who want to create more agility and resilience in their environment. And so we've used this chart on the previous sessions as well. Agility is marked by the ready ability to move with quick and easy grace. You can adapt very quickly to changes that happen. You're able to flex with whatever dynamics may be occurring in your market. And clearly, the more agile you make your supply chain, the more responsive you'll be perceived in the markets that you compete in, and you're going to be in a better place to stand ahead of the competitors that you face. Resilience is about the ability to recover or withstand difficult conditions. So a major storm comes along, there's a strike at the Long Beach port, you've got ways to deal with those kind of variations and impacts that can occur. And so when we think about our supply chains, if we can create more agility, if we can create more resilience, we're going to be in a better place. Now, up till now, planning systems have largely been predicated on the idea that start with a more accurate forecast and everything else will be fine. And yet we found that we don't really know what that future is going to bring to us. So I think that in reality, the truth is that to become more agile, to become more resilient, we collectively must embrace that the only certainty we have is that the future is uncertain. So embracing the certainty of an uncertain future, if we can get our heads around that and really understand that by doing so, we will look at how to improve our positions in a much, much different way. If I know I can't predict the future, then I have to build more adaptability, more flexibility, more resilience into how I operate today, which would then allow me to be much more able to withstand the variations and the other things that are going to occur as we go forward. And I think the more you can internalize this thought, the more it will lead you to taking decisions in a different way and moving in a direction that will help you a long way down the road. Now, the demand-driven adaptive enterprise model was described by the Demand-Driven Institute over the last several years, and it is very much the embodiment of what it takes to become more agile and resilient. The concept here is that this covers the landscape all the way from long-range future market-driven innovations or strategies that we're going to execute in our business on the right side of the chart over to pacing to actual demand, being able to take whatever orders come in today and ship very, very quickly and respond to those orders. And the continuum in between those two ends of the spectrum is kind of where we have the concepts of demand-driven S&OP that we covered in the previous sessions. Today's session is about scheduling and execution, which lives within what the Demand-Driven Institute refers to as the demand-driven operating model, which has two major components to it. How we manage our inventory materials and the product, if you will, within our environment. And then the second side is how do we manage our production scheduling and operations? How do we deal with those operating capabilities to enable ourselves to pace to the real demand that's in the market, utilizing S&OP as a vehicle for improving our configuration of that operating model. So we're going to live within the demand-driven operating model today and focus primarily on the scheduling and execution aspects of that. But suffice to say, there is a role for stock buffers and material positions and how they play into what are called control points in the DDOM that we will spend a little bit of time on. The whole philosophy, though, here is foundational to anything we want to do to become more agile and resilient. We had a meeting with Gartner last week, and we're talking about our strategies, and it was really encouraging to see that their focus is on resilient planning. And it is the advice to their clients is to not be so maniacally focused on getting your forecast more accurate. You have to look and shift it to a different mindset if you're going to create that agility and resilience that we're looking for. And we believe that the illustrations we'll share with you today and other things that we've done over this series are kind of foundational to getting you to a better place to be more agile and resilient going forward. So with that, we've got a couple polling questions. So if we could, Kevin, issue the polling questions. Okay, so if you could please respond on this and then contrast that with what are your manufacturing lead times. We'd like to kind of get a perspective on this, and we'll have some comments on this after we see the results.
All right, I'll allow a couple more seconds for last minute responses.
Okay, very good, very interesting. So we see 40%, 39% are saying less than 2 weeks, 50% in the 2 to 4 week range, and then some, beyond that 4 to 6 weeks. And then on the question of, is your frozen schedule longer than your manufacturing lead times? 50-50 or on that one. I don't know how we had more people respond. Oh, I see. It's 9 of 18 or 10 of 18. I don't know how we get those results, but we're about 50-50 on that front. And that's interesting. You know, the idea of your frozen period is intended to create some stability in operations and your environment. But oftentimes it's quite a bit longer than your frozen or than your manufacturing lead times. And that kind of begs the question is, why are we trying to freeze so far out into the future? And clearly, the more we can move to a shorter horizon, the better we are positioned to become more agile, because we are not committing production resources well out into the future. So let's take a look at this slide here. This is about how do we think of tactics in creating agility in our operating model. And obviously, we can't ignore the fact that how we're managing our materials, whether we're in a make-to-order environment or a make-to-stock environment, will paint this picture very, very differently. If we're heavily make-to-stock, then most of our agility is going to come from how well we manage our material and stock buffers. The more we align those to actual demand, the better off we're going to become. Now, there's still a scheduling component in this, because clearly we want to make sure that our production plans and our schedules are aligned to maintaining those buffers and keeping them well positioned. So there's still a scheduling component. We'll show you a little bit about that when we get into the software. If you're on the make to order end, and you have really no shared components or very few shared components and materials, then all of it's going to be about how able you are to utilize your production capacity and resources in harmony with what the market is asking. The more you can execute efficiently, hit your promised date performance, create better agility and flexibility with either alternate routings or other ways of working in your environment to give you a way to dynamically balance workloads and things like that, the better off you're going to be. The use of time and capacity buffers are really foundational to that. Time buffers help protect your constraint resources to ensure that they are always working and not causing a slowdown in throughput in your environment, where capacity buffers are going to play the role of insulating you from whatever variation by having enough sprint capacity or excess capacity that you're able to help catch up when and if variation does occur in your environment. Now, there's also a synergy between these two sides in terms of signaling. From a scheduling and execution standpoint, what we can pass along to the materials planning side are capable to promise or capacity tested due dates. In other words, can we actually achieve the planning lead times we have for our manufacturing operations or not? Are the orders going to be late or early? Those signals can be very helpful to how we manage our materials. And at the same time, on the right side here, the material positions, whether they're buffered or they are non-buffered, can create a prioritization scheme for us to ensure that the scheduling algorithms are being used to the best effect, so that we are ensuring that if they're buffered positions, they get the right level of priority based on how deeply the buffer has been penetrated. And if they're non-buffered, that if the prioritized date would be somewhere in the past, we're in a better position to overall respond there. And that's what the signaling between these two sides of Intuiflow can help with, because by getting better capacity tested promise dates on orders, we know if there are material synchronization alerts, we can utilize those to better address and triage any situations that need attention. And then vice versa, if we're using our buffer priorities or our stock position priorities to effectively drive the scheduling algorithms, we're going to ensure that what we're scheduling is going to be more in line with what we need to do to service the market. And I think this harmony between the two sides of Intuiflow is vital to creating the kind of agility and resilience that you're looking for. So we're going to talk a little bit about our scheduling and execution module within Intuiflow. It was formerly referred to as DBR+, heavily based on the concepts of the drum buffer rope application model developed under the work of Ellie Goldratt in the theory of constraints. It utilizes selective constraints as the pace setting resources within the scheduling, and then as well time buffers and capacity buffers that complement that to help us get the best due date performance and best stability within our operations. I'm gonna move this symbol up here. So let's kind of dive down a layer deeper now. The drum buffer rope concept is familiar to many in the manufacturing environment. I'm going to just go through this rather quickly. Drums are considered strategic operations. They have typically a limited amount of capacity, and they're going to become the pace setter for activity that flows through the plant. If you've identified that bottleneck or that constraint in a proper manner, and you schedule against that, you use it as the heartbeat or the pulse that you are going to issue work into the plant, you then are aligning and focusing your energy in a proper manner. Most of the time, it's going to be the slowest or most overloaded resource in the plant. It will be your drum resources, but sometimes the drum may actually be a wise choice to be a resource that has perhaps high levels of variation. And if we don't protect in that arena correctly, that variation is going to trickle throughout the plant. Maybe that's a paint booth operation or some other heat process or heat treating process that has fluctuations in throughput rates and things like that. It's a strategic decision to identify where your constraints are going to be, where your drum resources are. They become the pace setting resource. All the other schedules for all the other resources are going to be derived from what that drum resource can accommodate. The buffer is there as a time buffer. It's a pocket of time that we insert in the routing ahead of the drum resources schedule. This ensures that that work order that has that buffer will arrive on time, so that we are not frantically looking for material to come to that drum operation if the upstream schedules have somehow been disrupted. If there was a machine breakdown or labor availability issues or whatnot, there will be some type of variation in any kind of production environment. And obviously what we're trying to do is to protect against that. So the more effective we can deal with variation, the more resilient we become. Understanding it will allow us to use our capacity wisely. It'll also help protect our lead times and our promise date performance to the market. Obviously, the drum resources, since the concept here is that time lost on the drum is time lost to the entire system. So by protecting that drum resource, or you may have more than one drum in your environment, then we protect the throughput of the entire plant. And we also put buffers at the completion area, whether it's a stock buffer or a time buffer at the end on a make to order item. Putting some buffer time at the end of the schedule there also helps protect our promise date performance and gives us more flexibility to deal with whatever upstream variation that occurs. Buffers are applied selectively in our environment. We don't adhere to the idea of putting queue time or buffer time at every step in a routing. That time will get frittered away and not utilized. It doesn't create the visibility that you're looking for. We'll show you the buffer boards here in a few minutes in the software. And that's what's really critical to make sure that we're utilizing that time correctly. Goldrat's philosophy around project management was to not put buffer time on every task, but rather to put it at various stages of completion within a project plan. That's the notion of critical chain project management. And that's very much embodied in the way our solution works and the way we recommend clients try to deal with variation in their environment. So I think we have a couple more polling questions here. So hopefully these will go off a little more smoothly than our first go round. And so what we're asking is, what's your achievement rate on your schedule attainment? In other words, how well are you able to hold to your schedules within that frozen period window that we talked about in the first question? And then based on that performance, what is the most common factor for breaking your schedule? For those of you that have longer schedules, then you're going to be obviously more prone to break schedule break-ins and things like that. Pick the one answer here that most adequately describes the typical scenario that's erupted that has caused you to have to make a break in your schedule. We'll give that a minute for you to respond.
Okay, I'll give it a few more seconds.
Okay. Looks like the majority is in the 75 to 85% range. A few doing well above that at 95%. That's awesome performance. But typically, we're going to be down in the mid 80s to 90% range for a lot of companies that we've worked with. Some have even greater difficulty than that. And then if you can scroll down here, I guess we can scroll down on the results individually. What you can see is that the most common factor is pretty widely distributed here. The single most large one is lack of components and materials, followed by drop-in orders. That's very much a typical situation, machinery breakdown, or labor and availability skills. So labor availability or skills. So very much appreciate your responses to those questions, because those types of variations, those are the things that can impact our schedules. The better we can improve our ability to manage that, the more stable our operations environment will become. And we'll talk about this in the concept of control points here in a moment, where material availability has obviously been a major issue for companies in the past couple of years. Thanks for your responses there. Okay, so we know there's variation. It could be supply variation. It could be fluctuations in demand. It can be Murphy's Law, erupting within our environment. And then there can also be over and under reactions that imposed by management, decisions that we make that actually contribute to the variation and kind of the dynamics that we're dealing with. And clearly, the better able we are at managing variation, the more effective our operational environment will become. So we're going to go into creating a model, a demand-driven operating model. And obviously, the design of that model is going to involve a number of key decisions. What you see on the right is a process mapping view of a client we had worked with, which showed the path of routings of the various work orders. The heavier colored lines indicated greater volume and greater activity. The lighter lines indicated fewer of those. You can see some examples where there's recurring process loops on a given machine for different operations that might be in a milling environment and things like that. But part of the process is to analyze the environment, because you've got some critical decisions to make in setting up your demand-driven operating model. First and foremost, the identification of your control points and what constraints you're going to utilize in your production environment. You then need to classify other production resources, whether they will be a free resource, infinitely scheduled, or a free resource that has time buffers on it, maybe an external process, things like that, that is outsourced for various reasons. Clearly, we need to validate routings, run rates, and setup times. That core information is foundational to being able to get a good, stable schedule built, one that you can execute. And those run rates and setup times are important information that really contributes to that environment. The good news is once you start operating in the solution, you actually get feedback, and you're able to start capturing whether your standards or your run rate, setup times, and other elements within the routings are accurate, and dial those in over time to get them more predictable and more reliable in terms of your scheduling algorithms. Positioning and sizing of time buffers, that relates to our constraints. Not every time buffer needs to be as large. For example, items with upstream routing steps that are rather stable and simple and very reliable will not need as large of a time buffer in front of the drum resource as will a long routing set of steps that have highly variable activities within them. So we don't think in the context of a one-size-fits-all manner of setting time buffers around constraints, because really there's different levels of complexity in the various workflows, and you don't want to use a single rule to govern all of that. There may be opportunities for grouping where we can utilize and minimize setup times by grouping work orders together because they have certain like characteristics that we want to take advantage of. You can have sequencing rules as well that you need to respect, things like sequences as in color operations or allergens or other factors like that. You want to make sure that you're respecting those in how you build out your schedule. And then obviously one of the things that in generating the schedule, it generates the length of the rope. What is the duration of time from when we first release that order to when it should be completed in the system? And those rope lengths are very useful for us. We philosophize around or believe in a very much a choke and release. So it was good to see that there's a good number of you have rather short frozen periods. The more you can constrain your release schedules to a limited time frame, the more flexibility you have. That way, drop-in orders don't require an adjustment or a reschedule operation. They're going to slot in where they need to be. And that may be for a real high priority customer, things like that. But all of this is, kind of foundational to how we're going to plan to schedule and operate in our environment. So another chart from the Demand Driven Institute. And this is the idea of control points. You can see we've got stock buffers here, a make to stock end item buffer, and some stock buffers on supplied in materials. And these help create stability. We are insulating ourselves from supplier variation when we have properly deployed buffers of those purchased and bought in components in our environment. They may join the routing at various stages of the operational steps, but suffice to say, if we get those buffers in place, that is a major piece of the puzzle of getting more stability in our operation. So I kind of highlighted earlier that even though we're talking about scheduling today, proper use of stock buffers wherever they're appropriate can help insulate us from external impacts hitting our schedule. Now, drum resources are going to be your constraints. They're going to be your pace setter resources. And so time buffers will be applied in those environments. And then on other resources, you'll see what we're going to illustrate are where we have capacity buffers, where we want to have enough excess capacity to be able to support the drum and ensure variation does not cascade through it. So stock buffers are going to help us decouple supplier lead times, to insulate operations. Stock buffers may also apply at intermediate operations within your environment, depending on those kind of examples. So quite useful in helping us improve operation stability. And then the time and capacity buffers really help create the resilience and reduce the impact of variation cascading through the environment. Time buffers protect the drum schedule, and the capacity buffers also give us the sprint capacity we need to catch up when and if needed. Completion buffers or stock buffers at the end of the production process also help us protect due date performance by dampening the effect of upstream variation and not preventing us from shipping on time. In our S&OP conference last couple of webinars, we talked about the tactical review process of demand-driven S&OP. We talked about the fact that our stock buffers and their relative positions help us understand whether we have items that have stock out exposures, maybe need larger buffer settings. These were make items. It could be that our manufacturing lead times that we've assumed in the system are too aggressive and cannot be achieved consistently through our scheduling. And then we would want to address those and make sure those are corrected. On the other hand, if we're at the high end of the stock buffer, there's opportunity for working capital reduction and better alignment to market demand. On the scheduling side, we have the capacity buffers, and these are where we have the idea of having excess capacity. And there's another chart I'll show you here in a second, but the idea is not to get all resources activated to 100% utilization. While that may appear to give us a better cost per unit produced, oftentimes it introduces a lot more work in process on items that probably don't have a true demand pulse pulling them through the system. And that's not a favorable thing. That's not being agile and responsive or resilient. The time buffers, as we've said in the presentation here, are really there to give us protection. As work flows into the time buffers, and you'll see this in the buffer board, if they're coming too early, we've got too much WIP in process, our upstream settings may be inappropriate, maybe our routing run rates are too lenient or too conservative in the sense that they're giving us way too much opportunity to overachieve, and we've got workflow coming through, getting to the drum resource too early. Or conversely, we could be consistently late, where we've got machine breakdowns, other issues in the upstream process steps, and we want to make sure that we're protecting against those in the way we set up our settings as well. Time buffers have three that the red, yellow, green kind of concept, the same as our stock buffers do. The over top of green on a stock buffer translates into early from a time buffer standpoint. These zones are really there to help us monitor the flow of work orders as they progress towards that drum resource. And then clearly the lates are the ones where we really ran the risk of disrupting the other schedules and the other work orders that are flowing through the drum resource, or having the machine be idle for a couple hours while we wait for the upstream work to complete. That's obviously going to cost us because it's going to restrict the output of the entire production environment based on that impact. So we have another final polling question here, and this has to do with how do you plan all of your resources? Are you on the quest to get all of them fully utilized, or do you have this idea of sprint capacity in your environment?
Couple more seconds.
Okay. Over half of you indicate that there is a mindset of trying to ensure all resources are fully utilized, but a good percentage are saying no, and I think that's great. The idea of getting everything activated all the time does not yield the kind of results people think it should. It doesn't result in lower cost per unit produced. A lot of time it results in inventory buildups that aren't needed because they're not selling in the market. So having the judgment and the ability to kind of restrict that, to have some excess capacity around, are very, very helpful to creating more agility and resilience in your environment. So thanks again for that and your answers to these questions. All right. This is the key chart, and this is the one I would want to emphasize here, that the finance-oriented view of the world is that we want to utilize everything as much as possible because that gets us a lower cost per unit produced. So the green zone in that case would be items or resources that are pretty much fully loaded all the time. The red zone in this case would be items that have, or resources that have, a lot of extra time available to them. This is obviously very counter to a flow-centric way of looking at things. If we care about flow and we understand that level loading every resource across the entire plan makes us very brittle, because anytime there is any variation, it's going to disrupt a wide number of other resources in the environment. Having that excess capacity does give us flexibility. And it can range from everything to protecting against variation internally to being something that we can exploit at times. Maybe there's certain functionalities or capabilities that we have that are not that heavily loaded, and there's a market opportunity that we can increase the utilization of those to generate more revenue and profit for our business. But the more we can, other than in our constraints, follow this flow-centric mindset, the better off we're going to be. And it gives us more agility. I think everyone can understand that if I've got that extra capacity and I'm not fully squeezing everything out, then my responsiveness to the market requests that may come my way are going to be much, much better. And this is what it would look like. This is kind of another chart from the DDI, is thinking about this concept. The stock buffers are being utilized to insulate us from supplier variation. That was the biggest factor in terms of what was causing schedule breaks in your environment, per our polling question. The time buffers are here to protect us at the drum resources and at the shipping buffer to ensure that we can make our on-time promise date performance statistics go up in the right direction. And then having sprint capacity across the other resources within the production environment gives us that flexibility that we need to be more resilient, to be able to absorb variation, to be more agile. The color coding here is indicative of where they fall in the scheme of the capacity buffer concept. So this is kind of a good illustration. We've applied all the different buffering techniques. If you've been around the theory of constraints, you understand that Goldratt had a very clear vision around how buffering can help. And if you've applied TOC ideas, you've kind of gotten it in your gut that these things can be quite effective in terms of managing stock positions as well as our production resources. Now, the final stage, we've talked about drums and buffers, and we've looked at the different buffering from the standpoint of stock, time, and capacity, is the rope dimension. How do we synchronize our material release? The shorter we keep our release horizons, the more we increase our agility, because any new orders that drop in don't then require, if they're outside that shortened release horizon, give us the ability to include them in our schedule without disrupting a frozen schedule that we were kind of locked into. This gives us way more flexibility than if we've got a frozen schedule that goes several weeks out into the future, albeit it's well intended. It's intended to give us that stability. But as we know, work order or drop-in orders are a reality. Other breakdowns are going to be inevitable, and they're going to impact us. The schedule of the release of material is going to be based on our drum schedule. So all of the routings are going to be that run through the constraint are going to be scheduled in a manner. They're finitely scheduled to the drum resource. They are not going to be allowed to go into the past because we can't recreate time. And so our release horizon becomes kind of that schedule of orders as we should release out to the floor judiciously, maybe release the next day or two's worth of work. There is a timestamp on when that material should actually move out onto the floor to its first operations. That can obviously help on the logistical side of moving materials from the warehouse into the production arena and getting it ready for operations. If we release too early, we're going to have way too much WIP, and that reduces our agility and creates other problems. If we release too late, obviously that jeopardizes our control point or our drum schedule. So we want to be very mindful of those schedules and trying to adhere to those as we go forward. The rope is the summation of all the time from the release point to the front of the drum. And so that would include the drum buffer itself. So we're quantifying that time. That gives us an idea of how long we have from when we initially release to when that work order should arrive at the drum buffer. If we're releasing too early, we're creating WIP, we're creating variation. Clearly, probably the biggest point here is getting accurate run rates and setup times so that those rope lengths are accurate and give us reliable signaling points to work from in terms of material movements and things like that. So choke and release, the shorter you can keep that horizon, the better off we're going to be. And in the interest of time, I'm going to kind of jump through a little bit here. So those are the foundational concepts. Drum resources are going to be our pace setters, typically going to be the bottlenecks, but maybe at times resources that have lots of variation. And the better we can control that, the less we are going to have that influencing the rest of our operations across the environment. The time buffers are there to protect those drums. That ensures that the work across those resources, those precious resources, is there and ready to go when it's needed. It also provides a signaling mechanism that you'll see in the buffer boards here shortly. And then the ropes is really kind of going to dictate release schedules and the overall timing of the execution of work orders across the environment. So with that, we're going to go over to Intuiflow. We're in the environment. Now there's quite a bit to cover here. I'm going to try to go quickly. Clearly, when you're scheduling, you're managing the usage of time. And so we're going to start with a couple settings here that I think are important to illustrate that are in the environment relative to the scheduling arena. So we go to our processing tab, and there's some scheduling settings here where we can set how the scheduling engine is going to run. We can have different settings for how we interpret run rates, whether it's units per hour, hours per unit, minutes per unit, how we look at our buffers times in hours, minutes, or what have you. What is our preferred shipping time? That's going to affect that completion schedule. The buffer zone settings for the buffer sizes. Now, remember that the buffers on constraints can have different sizes. That's in what's called a product family. or a buffer family, kind of similar to what we do on the material side. It helps address different levels of variation. And then transaction settings, and these are going to capture whether we are going to record an early arrival at a drum, or whether we're going to record and transact late. And I'll show you this in the software. This is helpful for the process of ongoing improvement, factors that you want to set up specifically to help you get more insights as to how your operations are running so that you can continue to make your settings more viable. These can all be set location by location across a network of plants, or they can be done from a global level. On the other side, we have a concept called execution priority. And this allows us to set different statuses. So if we enable this, it allows us to say buffered parts that are stocked out get the highest priority, lowest number, highest priority. Min-max parts in a similar manner. If they're non-buffered, we have different rules that say that if the ideal start date for this work order would have been in the past to meet the customer request date, it would get its highest priority. You set these schemes because these can then influence the way your scheduling algorithm is going to prioritize workload or work orders, and that's going to synergize between our material signals and how we're operating out on the shop floor. Next thing we wanted to think about are time schedules. So there's quite a bit of flexibility. Not every plant has every resource working on the exact same schedule. So we can set up day definitions. We can then create week definitions. We can have different schedules for different, part of the plant may be running a double shift. Part of it may be running a standard shift. You can set up shift overrides, exclusions, all manner of other adjustments to reflect time accurately in your environment. There's going to be, maintenance periods for some of your manufacturing equipment, things like that can all be modeled into the software effectively. The resource editor allows us to set and define resources differently, including what schedule they're utilizing or whatnot. You can see here we've got our constraints. Buffered resources are going to be those resources that have a time buffer in front of them, but are going to be infinitely scheduled, and then resources are going to be infinitely scheduled, the assumption being that they have sprint capacity. You can set the resource calendars, whether or not a given resource is active. You can have standard buffers on these other non-constraint buffered resources. You can set a time in there. That could be something like an outsourced process, things of that nature. So with all of those settings going on in the background, we then can get to our scheduling environment. And this is the scheduler, a number of key features here, including a range of different views that you can create for your scheduling environment. Maybe you're working all the work orders that transit a given constraint, or you're working within a location or whatnot. You have the ability to create flexible views here. The scheduler itself has a number of other functions that we'll shortly illustrate here. I ran it a bit earlier today. You can see we've got everything sequenced here by planned release date. So those that should be released today come first, followed by those in the succeeding days. You can see indications of the end request date for the order, as well as the promise date, and an on-time or late or early kind of designation. When you select a work order, you can actually see its given routing and see all the process steps that are involved in that, what its schedule would look like. Here you can see for this one, it has a time buffer of 2 hours in front of the C1 constraint. And that is kind of what our schedule expectation is for this work order. We can also make edits. We can change to alternate routings. You can select a different routing if you wished to an alternate, you can have as many different alternate routings. This is a vehicle that allows you to then adjust and maybe balance some workload based on the way the schedule is playing out, that you can shift some of the work orders to different constraints as an example and get better on-time performance as a result. When we do the schedule, we have something called the resource load graph and system load graphs. And these are there to give us an overview of our production environment. You can see here, we're looking out over the window today out through September 6th. You can see there's something interesting. C1 is our main constraint. It is level loaded and finitely scheduled. R10 is not finitely scheduled, it's infinitely scheduled, and it's looking like it has a potential overload here. The gray bars indicate all the unreleased work orders volume that's out there. We're going to release some orders here in a minute, and you'll see how those are going to be factored in. The resource load graph takes us down to the resource level. I'm going to look first at our C1 constraint, and you'll see how it is finitely scheduled. We are going right up to the top of the capacity footprint that we have in terms of the hours per day. In this case, an 8-hour schedule that we're utilizing. If we look at that R10, we'll see a different environment. That was the one that showed on the system load graph, the heaviest overall loading. And you can see as we get out in time, we've got some peak load out there. If we saw this on a recurring basis, and we don't have other strategies, like we can't change the shift schedule for resource 10 or other factors like that, then perhaps we should consider changing our model, designating R10 as a constraint, because we can obviously expect to be able to manage on the fly this amount of overloading. In this case, yeah, we could probably balance the workload that week with a little bit of manual adjustments in the scheduling, but this kind of a condition, if that was a chronic condition, would not put us in a good situation, and that would be an example of making changes to make that more balanced and more agile. So what we'll do is I'm going to go ahead and release a few of these work orders. And this would then, so we're releasing kind of the work orders that are due to be out today. When I go back to my system load graph, you'll see now that the released work orders are represented on the page. Whoops. On the page in blue, you can see the released work orders are here indicated, and you'll also see a similar view of that when we go to the resource load graph, which is at the machine level or the resource level. So we got an idea now that the first few days of workload are already out on the floor for that environment. Once we have work orders released, and obviously we're not in a live environment, so we're not seeing the actual work that's out there, we'll have the benefit of the buffer board. And this is a key point of visibility in the environment. This is giving us visibility to the work orders that are coming towards that drum resource. In this case, it's the C1 constraint. And as time passes, there's the work orders will transit from early over towards the late end of the spectrum. And you can see we've got one over here that's already late to the drum resource. When that happens and they finally arrive, then we have the ability to transact this. So we're going to open up that work order, and we're going to say it's been received at the buffer. So we're going to be asked for a reason code for this, so that we can capture this for the purposes of ongoing improvement. In this case, the first step in this routing was the constraint itself. And let's say in this case that it was a material shortage. That was one of the conditions that you all highlighted earlier. What we'll do is transact that. That will say it's been received. If we come back to our buffer board, you'll see now that that work order is now received at the buffer. And now we have the ability to transact it again. And what we'll do is we're going to start that work order. Whoops, I'm sorry. We're going to start that quantity at the drum resource. Doing that, the work order will now disappear off the buffer board. In a live environment, you're going to see work orders in all of these different windows based on their stage of execution. This is a tremendously valuable tool in terms of shop floor visibility and execution. It gives us the ability to stand over the environment and have a much better ability as a supervisor to make on-the-fly decisions, agile decisions, if you will. If we find, for example, that some of the work orders or one of the machines upstream broke down, we may have to jigger our schedule of the work that we're going to put on that drum resource to protect it from being idle for some period of time in our environment. So resource load graph, system load graph, those are the overviews of how we're doing on the resources across the network. The buffer board is really more on the execution side now. The work orders are out there on the floor. How are we doing in terms of managing and progressing as we go through? There's also quite a bit of visibility in our Power BI environment. You've got Gantt charts that show for a given resource what its schedule looks like. These are all the various work orders that are out there. The buffer times are visible out here so that you can see them along the path. We have process mining flexibility. This is really, really helpful in terms of being able to oversee the different routings that we have in our environment. And I should have refreshed my screen again, Patrick. We should have had the ability to see the overall production environment from that standpoint. We're going to start here with a Gantt chart. Just give me 1 second. There we go. And this will show the overall process map view that we have in our environment. There we go. So you can see the routings. We've got a redirect here. It cycles back through R10 as part of its routing. Very great visual tools that helps users and the like go through that. So don't have time to go through all this, but tremendous visibility. One last thing I wanted to show here very quickly was this notion of, I'm going to go to our site admin, this notion of execution priorities, and we're going to go ahead and turn that feature on. I didn't have it on in the environment yet. So we'll go ahead and flip on the scheduling and execution priority functionality. And when we go back and run our scheduler, we should see our priorities will change now. So we'll go ahead and run the reschedule operation. So we're going to draw an end to the session here. We're going to try to capture any Q&A. Trying to get back to my PowerPoint here. I just realized we're getting quite short on time, and we're going to stop and see if there's questions, and then we'll have a couple summary comments. Miles?
Yeah, we have a few questions coming, Eric, and I do want to thank Wally for answering that question from Carlos earlier on. Thank you for that, Wally. First question for you, Eric. When do you start with a customer for scheduling execution? What is required, and what are some of the steps and timelines?
Clearly, dealing with scheduling is a different kettle of fish from managing materials. The operating environments all have a personality of their own. And so it's critical to gain an understanding of the client's operations environment, their production environment. Those are best accomplished through what we call design workshops. We're able to gather data ahead of time, come in and really walk the floor with the team, understand the challenges and operational environments in that environment, what are the issues that they're facing, and craft that design of the operating model that we talked about back on this chart here for their environment, looking at the process flows, the process modeling and things like that. So obviously you need to get your master data right. You're going to need to get appropriate decisions made around what are the constraints, what are the buffer times that we need to deal with variation within your production environment? What are your run rates and your setup times and your routings? There's typically a philosophical change involved in this, especially if you're in the environment where you're just trying to utilize all resources all the time. There's a bit of a perspective change that's needed. So obviously a lot of work on the data side, an understanding of the manufacturing environment, getting kind of a process view of it, or this kind of a view built and agreed with the team, and then obviously getting the data in such shape that they can actually get good value from the scheduling functionality.
All right, Eric, and one last question. We are currently in a back order, late situation across the factory. Would the tool help us to prioritize?
Yes, absolutely. But it also is going to involve some of your own judgment in that environment in terms of what are the most critical customer needs that you want to deal with. At the end of the day, we all have a Pareto curve of our customers, some with a much louder voice because they represent a larger portion of the revenue that we generate. and you need to be sensitive to that there's other factors outside the sheer scheduling requirements that you're going to want to pay attention to. But I think absolutely one of the use cases that we have for our functionality that we've done has been developing constraint-based master production schedules. Part of the problem companies are having is still that there are external constraints in their supply community that they can only get certain materials at a certain rate. And if you're trying to schedule beyond that, then what you're actually going to end up doing is driving requirements for non-constrained materials much higher than you're actually going to be able to consume. And that's not a good thing, because now you're going to see inventory going up, even though you're still dealing with these back order situations. So you want to be careful about that. We've got a scenario that we can illustrate around doing a constrained master production schedule to moderate the amount of buying in of other materials that can't be utilized yet, and utilizing that supplier constraint to kind of throttle back operations. It may expose and reveal some excess capacity you've got that you may find other uses for, so that you can optimize that on those opportunities while you try to resolve those external constraints. Okay, just in closing, I think from a scheduling and execution standpoint, there are lots of opportunities to create more agility and resilience in your environment. This concept of time and capacity buffers cannot be underestimated in terms of the value that it can create in your environment. Oh, Jesus, went to the wrong button there, sorry. And so considering where do you apply those, what are going to be your constraints, how do we build in capacity buffers, how do we leverage that in a better way, will do an awful lot for us. We can improve resilience by managing variation. I can't say this often enough and strong enough that it's managing variation that is really the key to all of this. And the more we can exploit buffering concepts, whether it's stock, time, or capacity buffers, the more control we're going to get in our environment. And then finally, the more we can shorten our release horizons, the better off we're going to be. We become more agile by definition. Drop-in orders, other issues don't present as big of a challenge as they do if we've got an extensive 4-week frozen period and we find ourselves firefighting and breaking the schedule multiple times a week, because things change. And that's that uncertainty that I was talking about in the beginning of the presentation. And then finally, we can improve the stability of our operations. It shouldn't be so hard. Our team was with a client last week. It's like crisis of the moment, right? And you don't want to be in that kind of environment. You want to gain control of your environment. These buffering concepts we've talked about can do an awful lot to help with that. And obviously the solution is built to really deliver that kind of value. So with that, I'm going to say thanks to all for your attendance and your participation in our polling. We are going to include the responses in the PowerPoint that we send out later today of the presentation, so you'll be able to have those for reference going forward. Want to wish you all the best today, and the best on your path towards a demand-driven journey in your own environment. So thanks all for everyone for your attendance, and we'll talk to you soon. Thanks, everyone.